Okay, so here are some volume problems. The key to these volume problems, very similar to the way that we do our area problems, you have to have an accurate picture of what's happening. So that's a good thing place to start, okay? So let's take a look at what we got here. So we have a parabola, not a parabola, goodness gracious, a square root that is moved to the right one. You'll notice that 5 has come up as an x value, so let's definitely graph it up to 5, because 5 is kind of a little barrier here. And then we've got a little barrier here. And so if you graph it fairly accurately here, you get this, okay? And we want this area here rotated about the x-axis, okay? Now, let's just contemplate what our volume, our picture is going to look like. So it's going to kind of look like this. Okay? Okay. So what do we know? Well, let's set it up. So remember, for the most part, it's from A to B, pi f of x squared dx, when it's rotated about the x-axis, is kind of a good rule of thumb to think about when you do that. And this is a good time to use that. And so we're going to go from 1 to 5 of pi square root of x minus 1 squared dx. Now what's great is when we square that square root, the square root pops off. And we just get, let's stick my pi in there. Here, let me erase that so you can see the pi a little better. The pi is just a constant. You can put it out front, or you can put it here like I am, whatever you want. And so then it's just a general antiderivative. And so we get pi times x squared over 2 minus x, evaluated from 1 to 5. So we get pi times 25 over 2 minus 5, that's a 25, minus pi over 1/2 minus 1, and you get pi times 12 minus 5 plus 1, which is 8 pi. So there's our first problem, number 3. Now let's go ahead and do let's do number 11. Now this one's a little more difficult, that's why I wanted to do it. We are rotating about a line y equals 1. Again, accuracy of your picture is very important, so let me draw this for you. Our first y equals x squared is just a parabola. Our x equals y squared is a parabola laying on its side. So if you solve for y, see how you get the square root of x. You can kind of already see that this is the area we're discussing right here. But here's the kicker. We want to rotate it about the line y equals 1. Okay? So if we think about it, we're going to get like this little piece here, and that's going to be it's going to be rotated about there. Okay? Let me take that off so we have a little more to go with. Okay. So what do we know? Well, this piece here, well, what is that? Well, that hits our parabola, x squared, but we don't want this area here. So we're going to go from 0 to 1 of pi 1 minus x squared as our outer radius, minus pi, let's do our inner radius, okay? So that's going to be this right here, which is 1 minus the square root of x. Okay, so now we got it set up. Now, you physically want to actually square that out. Let me show you what I got. I got 1 minus 2x squared plus x to the 4th minus 1 plus 2x to the 1/2 minus x. Now, I'm going to combine like terms. I'm going to put it in descending order just so it'll make my brain a little happy. Get x to the 4th minus 2x squared plus 2x to the 1/2 minus x. Now it's just a standard antiderivative. So it's x to the 5th over 5 minus 2x cubed over 3. Now here, our x power is going to go up to 3/2. We have to multiply by 2/3, so that's going to be 4/3. And then we got that. When we plug in 1, we get 1/5 minus 2/3 plus 4/3 minus 1/2. When we plug in 0, we get 0, so we don't have to worry about it. And we get 11 pi over 30. So the setup for those ones, like when you go about a line, you sometimes have to do that subtraction like we saw in there, okay? So now let's try one of the ones where they say a region. I wanted to do one of those for you. 19 says the region R1 about the line OA. So we're going to go about this line, and this is the region they were talking about right there. Okay. So what I noticed was the line was the perfect y equals x. And you can do that. Think about it. Started at 0, 0. It went up to 1, 1. You know, it has a slope of 1. It has a y-intercept of 0. However you want to think about that. So the setup for this is from 0 to 1 pi x squared dx, which is pi x cubed over 3 from 0 to 1, which is pi over 3. So don't make those harder than they are. Some of them are harder than others depending on how you rotate, you know, but I did want you to see that, okay? So there are some volume homework problems for you to look at. Thanks, guys. Bye.